So I'm now going to take you through how to use tools to analyze most of the common open respirometry data that we're going to have in the Onthank Lab. So the very first thing that you need to make sure that you do is have tools installed in Onthank. And if you don't know how to go back back to the video I had earlier going through that, but once you have that installed, go to the Packages tab over here, the lower right hand window or pane in our studio, then just scroll down to get to the O's and click on OTools. This particular time I'm using OTools version 0.2. If you have a different version, this might be slightly different. So the very first thing we need is make sure that our working directory is set to where we have our files. I've done that, but if you have not, go into the session and set working directory and choose the directory and make sure that you set it to where your files are that you want to analyze. And then once we do that, what we do is we go to files and actually see those in here. I brought in two files, and you should have two, generally have two. One that actually is the respirometry run, where we had the ocluses or whatever animal we had in the respirometers, and then another one on the ground. The very first thing that we need to do is read this into R, and so we do that by just using this function right here, read.pyro. So we use that, and then parentheses, the only argument we need is the name of the file that contains respirometry data. So in this case is 072214-14-11.txt. In this case that was the date dash the octopus number in respirometry 1 dash the respirometry data, or the octopus in respirometry 2, all about txt. So we're going to do that by just using putting our cursor on the line, hitting Control Enter. It will run that command. One thing that you might notice is that I'll say warning messages, NAs introduced by coercion. That's normal. That will typically happen. Up here in your environment, you should see that data set show up. I just named it data for the sake of this particular example. You can call it whatever you want. If we go ahead and click on there, it will bring up our data, and you should see something like this where we have date time S, which is the time in seconds, and then O21, this is the oxygen levels in channel 1, O22, the channel 2, O23, 4, and then we have temperature, temp 1, 2, temp 3, temp 4, this is the temperature channels, the pressure, humidity, and all the rest of the fields that are in that data set. We keep them all, but really it's going to be needing the temperatures and the O21, O22, O23, O24, etc. So we go ahead and do that for the main data set. We're going to do essentially the exact same thing for the background data set as well. So here then we begin using read.pyro, and again the only argument is the name of the file that we're using. I'm just going to call this data.back to differentiate it from our main data set, that this background data set. So I go back to there, hit Control Enter. Once again, it here, and once again it brings up a warning message, and is introduced by coercion. No problem. The very first thing that we need to do actually is then to find out what is our background from the background file. So we use the function here called back.pyro. And this is going to take a couple different functions now, or a couple different arguments. Number one, the argument that needs here, first off, is actually that we put our background data into. So that's data.back. And then we need the flow rate for those respirometers as well. So let's imagine that we had 150 milliliters per minute was our flow rate through those two respirometers. This is actually taking this in liters per minute, so we would put flow 1, the argument for the flow through respirometer 1, and we would put equals 0.150 for 150 milliliters or 0.15 liters per minute. And we do the same thing for flow 2. how there are more arguments that actually interact up Pyro. Let's go to packages and again go down to OTools. Click on OTools, bring up all of the functions. We go to Pyro. We see that in here we actually have arguments for in1 to out1. This is actually the channels. We can also rearrange the inflows and outflows for both of the respirometers. So for instance, normally we have the inflow for respirometer 1 is channel 1, and the outflow for respirometer 1 is channel 2, and so that's the default here, and it just automatically assumes that. However, if we have a different arrangement of channels for the inflow and the outflow of those two respirometers, we can manually set that here. So I just want to point that out with the back.pyro. Normally, this will not be the case. You will not have to set those. If you were doing this in the Onthank Lab, we tried to make sure that we have those channels on those particular respirometers. But if that's not the case, we can reset that. Okay, so we're going to go ahead and run this. Let me go ahead and run this without assigning it to a object and show you what it does. So we're going to run this, and what it does is it brings up a graph here of actually have the background oxygen consumption rate in that respirometer. And so what you see is it actually comes for ways here and then levels here to the right. And what we want to do is we want to capture that level off period here. So I'm going to click. What we need to do is we need to tell R that we just want to use this stable period. And so what I'm going to do is I'm going to click on the beginning and the end of that section that I want to use, and I'm going to hit finish. That'll bring up second, and this is in the second respirometer. Where is that stable? And I'm going to say it's about 40 out to about 5 here. You click it once at the beginning, once at the end, and click finish as well there. And what that brings up when you're all done is it returns two values. This is essentially the background oxygen consumption rate in respirometer 1 and respirometer 2. So let's go ahead and I'll just make that whole function again equal to back. So we're assigning the output of this function to the object back. We do that again, and once again I just set the beginning and end of kind of the level period of that background. And now we have this object up here called back that is the actual background value for those two respirometers. We are now going to use that when we actually determine the respiration rates that we measured in each of those. So what we need is this function, resp.pyro. Resp.pyro is the function that calculates the respiration rate for all of the flow-through respiration that we're doing in our respirometers. So there's a few arguments that we need for this. The first one is the object in which we put the main respirometry data rate, or the data set. So we just put that in as the first argument. After that, again, just like the previous function here, back.pyro, we also have to assign the flow rates in there. So in flow.1 is the flow rate in respirometer 1, and again, if this was 150 milliliters per minute, I would set that to 0.15 for 0.15 liters per minute. Same with flow 2. And we also have to assign the weights of the optodes that were in those respirometers. So in respirometer 1, I'm going to assign this to be 230 grams. So again, this is in grams. So the weight of the octopus in respirometer 1 was 230 grams, and the weight of the octopus in respirometer 2 was 168 grams. So we put those in there. Then we also have to tell it what the background rate was. Now, it will assume a background respiration of 0, nothing, but we do want to include those in here. Now, if you remember, we put both of those values into this object called back. And so if we make that equal to back, and then we use brackets 1, that's going to assign this first value as our background rate in respirometer 1, exactly what we want. And then back 2, we can assign this to back and in brackets 2, so that we have that value there. Now, what you want to do is, no, excuse me, let me back up. You notice I'll have this on several different lines, as long as this is the same as writing the file on one line. I just did this a little easier to follow. But if I make this entire function on one line, I don't really do anything differently than what we had done before. So I'm just breaking this up into multiple lines, and that runs exactly the same as if it was all on one line. Okay. So I'm going to assign this an object, and let's run this entire thing. So we highlight the entire function, Control Enter. And again, like before, what you're going to see is you're going to see a graph over here. And this is a little bit hard to see, so let me blow this up. And you can do this as well when you're actually running this. But what you'll see is actually you have some upper area here, and it begins to flatten out up here. What we want is we actually want the stable area of the respirometry if we're just trying to get base rate. But if we're doing something like a critical oxygen pressure or something like different temperatures, you actually might have different respiration rates all throughout this entire time. What we want to do here in this graph is just set what is the range that we actually want to take the respirometry from. So I'm going to go and say, oh, okay, it comes down, then it kind of reaches here. So I'm going to start the area that we're taking for measurement here, about 150, and then go up here to a little over 1200. So there we go. We've gone from 119 to 1256. And if we hit, as soon as we hit both those, it says OK. And it actually assigns that then to our object resp. So now if you look at what we got out of here, what this returns is resp1 is a respiration rate that we have calculated in respirometer 1. We've also 2. This is the respiration rate we have calculated in respirometer 2. And it also has oxy 1. This is the oxygen level in respirometer 1, and the oxy 2 is the oxygen level in respirometer 2. So there we have calculated the respiration rate of the organisms, or in most cases the octopuses, in each of those respirometers. That is our data. If we come down here, however, we can pull data from our data set also. So let's just imagine here we want to pull the temperature values here and add that to our data set as well. Well, we have temperature 1, temperature 2. These are in columns. Let's see here. Let's look at count over. Let's say day 1, 2, 3, 4, 5, 6, 7. So O24 is the 7th column. Temp 1 is 8, 9. So temp 2 is 9, and then temp 10. Temp 4 is 11. So let's imagine what we do in temp 4 and add that to our data set that we got for respirometry. So we want columns 9 and 11 right here. What we can do is I can remember that we actually grabbed data points 119 through 1256. We set that in as our, well, let me just talk about this from the beginning. So what we do is we can say data $temp2 is the column we want to add, and then the rows that we want to add, or the data points that we want to add, are the same as the data points that we actually took the respirometry from. Now, when we actually assigned the beginning and the end of what we took, it conveniently told us what those values were. We went from 119, the 119th data point, to the 1256th data point. So we can set that same range, and so we're getting the exact same temperatures for those exact same time periods that we have set the respiration to. So we just set that in there. We do that the same for temp 4. 19:1256. Now if we run that cbind and actually make this resp equals, we will actually turn resp into the combination of what resp was before, whatever columns we had, plus temp2 plus temp 4. So let's go ahead and run that. We come back in and look at resp again. So oxy 1, oxy 2, resp 1. Then we have that data the temperatures for that same time period, and over here temp 4 as well. So temp 2 was the outflow of respirometer 1, if you remember. So that this is actually the very close to the temperatures that were in that respirometer, and temp 4 is the outflow of respirometer 2. So this is to those temperatures. But you notice these are really kind of ugly. These are ugly column names here. Let's make those something different. So let's just do that by using the call names command. And we go call names and parentheses. We type in the object that we want. We go equals, and then we can just say again we want oxy 1, comma oxy 2. These are just the column names that we had in there before. We have resp 1, comma resp 2. Making sure that we're putting each of these in parentheses or and then also putting a comma between each of these. And we're going to put temp 1 because this is a temperature in respirometer 1. We're going to put in our quotation mark temp 2, or the temperature in respirometer 2. Hit Control Enter, and now we what we should have is this respiration rate in the organism 1. This respiration rate of the organism respirometer 2, and then we have the temperature respirometer 1 and the temperature in respirometer 2. Now this is ready for any other analysis that we want to do, such as comparing temperatures to the respiration rate, the oxygen levels to the respiration rates, or something else like that. Okay.